Here we go. Well, sometimes they tell you what they want, and sometimes they tell you you can do any way you want. Make sense? Okay. So, first off, let's talk about completing the square. I think that's one that we usually need to spend a little bit of time on. So I'm going to have you guys give me 1 second. Okay, you 3 rows. You're going to tell me what this is. You 3 rows, you're going to tell me what these are. Just for remembrance, when I see x plus 3 squared, does that mean x squared plus 9? Because I cannot bring a squared through a operation sign, meaning a plus, okay? Or a minus, things like that. So, I would have to do, if you'll recall, x plus 3 times, and then I'm going to distribute or FOIL, depending on if you ever heard that. Does that make sense to everybody? Okay, I'm going to push pause for me to bust through them really sad. Okay. So, really quickly, the first one, we should have got x squared plus 6x plus 9. What do we get here? X squared minus 10x plus 25. Bottom one. X squared plus 18x plus 81, right? Any questions so far? Top one over here, what do we get? Woo! Get excited, people, because that was fun. Okay? Not really, but maybe I'll shut up. Okay. So, can anybody see the pattern? Go ahead. Double what? So let's use this one. So use it a little bit better for me. You double this number, and then the third term is m squared. Double, squared. Double, squared. Double, squared, right? Double, squared. You get the idea. Okay? So, a little bit further down, what if I gave you this guy? See if you guys could get it without having to go ahead and FOIL it. Because the goal is that you guys can see this pattern, because that's going to help us complete the square. Okay? So this should be, Trevor? Double squared, right? Okay, now, notice, guys, that's what we took a binomial squared and turned it into a trinomial. This is called a perfect square trinomial, just like this was a perfect square trinomial. Yes? Shouldn't it be 2bx? Nope. Oh, yes, sir. Thank you. You're right. I apologize. Okay. So, with that being said, I want to know what is this as a binomial squared? We're going to go backwards now. We're going from the trinomial backwards. Now, I could factor it like we did yesterday. It would take me some time, but hopefully you can also see the pattern. This is a perfect square trinomial. How do I know it? Well, what's half of negative 4? -2. And if I square him, does it become 4? So shouldn't this be x minus 2 quantity squared? Okay? Let's do another one. Oh, frickery cracker. X squared minus plus 9/4 x. Ooh, I just made a fraction. No, that's not a good one. Shiz. Backwards. Where's my undoer? Squares and undoers. Oh, let's do 3x. That's okay. Okay, that's a perfect square trinomial. Now some of you guys are like, we have to use fractions. That's right, that's my favorite right now. But fractions aren't hard, guys. You guys don't like them because they take extra work. Really, that's what it is. Because are they really hard rules? What's the rules of fractions? When I add fractions, what do I have to do? Common denominator. When I multiply fractions, what do I got to do? Straight across. When I divide fractions, what do I got to do? Times by the reciprocal, right? Those are the 3 rules. Are those really that hard? No, they just take extra time. That's why we kind of did it. Okay. So, once again, what did we do here to find out it was -2? We cut him in half. Well, what's half of 3/2? 3/4, right? Because I'd go 3/4. Remember, if I'm cutting something in half, times by a half. Oh, sorry, that was a 2 already. And the 3/4. Now, when I square 3/4, do I get 9/16? So all this is x plus 3/4 squared. Okay. Now I gotta remind you guys, once again, I'm trying to get you to remember this rule, but we will be getting to solving quadratics today. That's our goal, solving quadratics, but I gotta get you guys to do these ones first. Okay, so, with that being said, okay, what would fill the blank to make that a perfect square triangle? 36. How does 36 come about? So, once again, cut him in half and then square him, right? That would make it a perfect square trinomial. So half of 12 is 6. 6 squared is 36. Now, what would be the binomial squared to this? X plus 6 squared, right? We all good with that? You guys remembering completing the square? Now, to be honest with you guys, if you'll look over on this one, notice, what's my leading coefficient right here? 1. If it's not 1, don't complete the square, okay? It's not as easy to complete the square when it's not a 1. I'm just telling you, unless we have to do so, like it tells us to, then I wouldn't do it. Okay? Does that make sense? Because it's not the easiest method anymore. Probably the quadratic formula would be where I'd go from there. Okay? Make sense? Okay. So, with that being said, I'm going to write an equation here for us. Okay? X squared plus 6x minus 21 equals 0. Okay, I actually want to know what x is. I want to know the values of x. Okay, but I want you to do this by completing the square. Okay? Want this done by completing the square. Is this a perfect square trinomial? It's not. What number would need to be here to make it a perfect square trinomial? Positive 9. A 3 is what half of this is, and then we square it, right? Oh, that's 9. I have no idea. I only know a few words in sign language, and one of them uses this finger. So, and well, yeah. Shut up, Robert. Here we go. So I'm going to get rid of this 21. Because he doesn't make him a perfect square. Where do I need to get him to? The other side. Okay? Did I change the value of that equation? No, because as soon as I got into the other side, I made okay, right? Because I did it to both sides, correct? Okay. And as you guys all said, what should fit that blank? A 9. So can I just throw a 9 in here? If I throw him in here, I'm okay. But did I change the value of my equation? Sure I did. So to balance him, on one side I added 9, so the other side I need to add 9. So good? Any questions? So what are we left with here? What's this? That's the whole reason why we just did this. X plus 3 squared, right? Because we went from a perfect squared trinomial into my binomial square. Okay, what's the other side equal? 30. It is HK, if you think, but not really, because this is not the stuff. But you can have it in vertex form. But we're solving. I want to know what he is. So we need to get rid of the squared. What do? Square root that sucker. Is this green okay, or is it bad color for you guys? Is it all right? Could I use that color if I wanted? Now, ladies and gentlemen, let's see if you remember. What did we forget? When I take a square root, I need a plus or minus. Right? Okay, so this is x plus 3 equal plus or minus root 30. Can that square root of 30 be broken down? What's in 30 really quick? 6 and 5, 2 and 3, notice. No buddies. I know Miss Merkley's like, they get out of jail and one gets shot. Something like that. Am I correct? Yeah. No buddies. Okay, so we just leave it here. Are we done? Are we solved? No. We need, last but not least, subtract that 3, so our answer is x equals negative 3 plus or minus root 30. I like the number in front of my plus. Okay? There we go. Now, just because we can, I'm going to take this exact same question here and see if we get the same answer by doing quadratic formula, okay? Did Miss Merkley or Mr. Benight or Mrs. Burton or Mr. McDonald ever show you why quadratic formula comes to that? I can hurry and show you a little later. If we have time, I'll show you. Okay, here we go. We are singing, every single one of us. You are not too cool to sing. Okay? I'm going to tell you first, and then you're going to sing with me. Okay, here we go. So, here's the formula. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Okay. Here we go. I want every single one. If we don't get every single one, I will make you do a solo. I'll find your mouth in it. I will come up. I know all the tricks, people. Okay. Here we go. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. So Thunder Vision back in the day, like a long time ago, when they weren't very good, they actually got this trash can. They're like, Mr. Roberts, I was walking down the hall. They're like, hey, I'm doing my homework, can you tell me that? And I'd be like, singing the song, right? They filmed me, and all of a sudden, this kid jumped out of the garbage can and scared us. Anyway, okay, let's ready talk. Who's Who's my a value? 1. Not x squared, it's the value in front of x squared, right? Who is my b value? 6. My c value? Negative 21, right? Everybody with me on that? Remembering that? So far, is anything new today? It might be sweeping cobwebs again, right? Is anything new today? No. Okay, here we go. Some people say instead of negative b, they say opposite b. So here we go. X, even when I plug it in, I see x equals negative 21 plus or minus. Oh, shiznit. No, that ain't it. Sorry, I'm getting all excited and stuff. Negative 6 plus or minus square root of 6 squared minus 4. Oh, that looks like a b, but it's really a 6. 4, a is 1, c is negative 21, all over 2 times 1. Okay? You blow that nose, Jenna. Okay, here we go. Can't do anything here. That's 36 minus, a minus and a minus makes me a plus 84. Did everybody see that? Just did that quickly in my head. Bam! What's 36 plus 84? 120. Okay? Can we break down 120? Well, let's check. What's in 120? 12 and 10, right? 6 and 2, 2 and 5. There's a buddy. And notice there's that 6 and 5 again, which we know we can't break down. Okay? We already did that on the last part. Everybody there with me? Okay. Let's drop. I don't know. Basically, I might plus 305. I know my left side's bigger than you guessed. Maybe. Did anybody say wait, or am I just hearing stuff? Okay, keep on going. So, negative 6 plus or minus root 120 is, remember, 2 root 30. Yes? So if they have buddies, they get to come out. If they don't, multiply them together. Okay? Is that exactly what we had last time? Not quite there yet, huh? What do I need to do there? What do they all have in common? This guy, and this guy all have a 2 in common. Do they all have to have it? Yes. Let's say this is a 5, a 2, and a 2. Can I factor out a 2? No. I have to do it to all 3. Okay? So that becomes negative 3 plus or minus root 30 all over nothing. So there it is. Is that what we had on our previous example? That was the same example. Okay? Once again, multiple ways to get to the same result, right? Is this a difference of squares? The sum of squares. Can we factor sum of squares? Yes, in a way, but not in real numbers. You can use imaginary numbers and it happens. But we're going to solve this just by square roots. So this would be x squared equals negative 4. See how I just got it to the other side? Now if I was looking for our real answers, is this possible? Real answers? Why? Can anything squared ever come out negative in a real solution? No. No. Hence why the imaginary solution. Yeah, I really wish they would call them other than imaginary, because everybody's like, why do we use them? They're actually very useful in many applications, especially I don't know how. I've been told. Because everybody's like, where do I use this in the real world? I'm like, I don't know. This is my real world. True? Okay, so what do? Square root. When I take a square root, what do I need to do? Plus or minus. You guys know how much this kicks people's butts on tests? The plus or minus? You forget. You start getting it in your head when you take a square root. Plus or minus. Do I need to do a plus or minus when it's a cube root? Just curiosity. No, because it's an odd root. An odd root can be negative, can't it? So x equals plus or minus. Now this is the square root of negative 4. What's the square root of 4? 2. But remember, square root of any negative number is 5. Okay. Just making sure I'm hitting all the big marks today. All right. So, let's just go right here. All right, what are the 3 ways that we've talked about to solve quadratic equations? 1, we learned it last time, which is factoring first, correct? I'll show you how we actually solve factoring. We haven't done that yet, but we can. Okay. 2, completing the square. Would I complete the square on this problem? Why? Our A value is not 1. Could I complete the square? Yes. Do I want to? Not only no, but a hell no. Okay, I don't want to. 2, 3. I'm on 3. 3. What's the last one? Quadratic equation, right? Formula. That's what I meant to say. Sometimes in my dreams I have to. Huh? Oh, I'm going to actually start growing it after Labor Day. My wife said I have to trim it, and I told her no. Just let it grow. It goes over my lips, and I can suck on it. That's what it is. It's a flavor saver. Okay, anyway. My first thing I want to always do is, A, I prefer to factor. If I can factor, I'm going to factor. Well, what's the one way that I can do every single time? Quadratic formula, right? That's the one I can do every single time. But, me personally, I believe factoring is easier. So, I say, okay, can we get to 2 from the factors of 24? Negative 24, so it's going to be subtraction. Can I get to 2? You remember 4 and 6 would get me there, wouldn't it? Correct? Okay, so I'm going to use those and say, all right, 3x squared plus 4x minus 6x minus 8 equals 0. I had a few people come in and get help, and they got stuck up. Ooh, that's almost kind of bad. I don't ever use that word, though, so anyway. They got stuck a few times because they weren't getting the right thing. Now, the reason why is they'd make him a negative 4 and a positive 6. That changes the whole equation, doesn't it? We didn't make it the same equation. We didn't expand the same equation. We made a new one. Once again, one of your steps on checking factoring, is this equivalent to what you need it to be? Right? Okay? All right, then we're going to group. What does this guy have in common? X. Left with 3x plus 4. Sorry, this side of my big window. What do these guys have? What kind of a 2? Okay. What do we factor out? Your mom's dialogue. even take me. I just said, Mom, stay home. I'm leaving by myself. I left on my own. And she gave me a hug and I just, yeah. Okay, what does this say? Somebody tell me what this is saying. Basically saying this binomial times this binomial equals 0. So when we're having something that are multiplying or using multiplication, how does something get to be 0? One of them has to be 0, huh? So we're going to say to ourselves, okay, when does this guy equal 0? And when does this guy equal 0? Because those are the opportunities that we have to get this equation to be 0, correct? Does that make sense? So I say, okay, 3x plus 4, we're going to find out when it equals 0. X minus 2, we're going to find out when he's equal to 0. So what is the value that x is 0 in this equation? 2. What is this one? So x, so we're going to subtract the 4 over. Sometimes I skip steps, but then kids are like, I don't get it. Is that negative 1 1/3? No. Is it negative 1.333333? No. Decimals are of the devil, people. Do not use them. I'm just going to tell you right now, if you use a decimal on my test, unless it started with a decimal, you shouldn't end in a decimal. Okay? Everybody with me on that? You understand the rule. I like improper fractions. Decimal bad. Okay, I'll put that down. Decimals are... That's my devil. Okay.
Should we write this down?
If you want. Okay, there's my 2 answers right there. Really quick question. How many solutions can there be when you have a quadratic equation? What's the most you can have? 2. You're right. What's the least amount you can have? Well, 0 real. But I always will have how many solutions? 2. Now, I could have 1 solution, but that means that that solution is being twice. Does that make sense what I'm saying? Okay. So for example, if I did the quadratic formula, and it came out like this, 4 plus or minus root 0 over 2. What's the square root of 0? So then that's 4 plus or minus 0 over 2, which is just 4, right? But notice we have 4 plus 0. 4 divided by 2 is 2. 4 minus 0, that's the other one. The same result, but it happened twice. Called the multiplicity. We're going to talk about that a little deeper in a couple chapters. But this actually has 2 solutions, but they're both the same result. So when you see a quadratic, how many solutions are you going to have? 2, but it might only see as 1. Okay? Will you ever have 0? You might have 0 real solutions, but if there's 0 real solutions, that means there's how many imaginary? 2. Does that make sense to everybody? Okay? All right. So if I gave you a graph, how many solutions do we have? 2, but they're going to be 2 imaginary, because notice I never crossed the x-axis. Okay? That's when y would be 0. Or what the equation. How many solutions? Imagine it only touches 1, but it has a multiplicity of 2, meaning it only crosses it once, but that is being a double, like I said, on that 2 and 2, right? And then, I know that's a little confusing, and then last but not least, how many times is that? Twice. We have 2 real solutions. Does that make sense to everybody? Okay. Now, let's say they told us that this was a solution to a quadratic, and this was a solution and this was a solution to a quadratic. What's a possibility for that quadratic equation? So notice here, I'm going backward. I give you the solutions, right? And I want to know a possible equation. Okay? Does that make sense what I'm asking? I give you the solutions. I'm asking for what is a possible equation. Do you guys understand there's an infinite amount of equations that could have these answered? Okay, and here's the reasoning. Okay? Think about this. If I have that, notice it's crossing, here's 1, here's a half right here, right? And -4, I shouldn't use blue, but I could have it really thin, right? I could have it like that. Those are just 2 right there. Does that make sense? Using the same zeros. So do you guys understand there could be an infinite amount of equations that could do this? Right? Okay. Anybody have an idea of what we're going to do? If these are a 0 or a solution, we want this side to be 0. So we get them to the other side. The only thing on this one I don't like is I don't want it to be x minus a half. Okay, anytime you have a fractional value, I would like you guys to times the 2 over. And then subtract the 1. Sorry, say again. What do we need to do to this guy? Just add 4. Notice, there's my 2 binomials, huh? Right? So I have 2x minus 1 and x plus 4. Is that it? Is that what I want? Is that a quadratic equation yet? Mm-hmm. Almost, right? We're almost there. What else do we have? We're going to hurry and distribute, and I get 2x squared plus 8x minus x minus 4. So I have 2x squared plus 7x minus 4. There is a possible equation. That is a possible equation for those zeros. Okay? Now notice if I times everything by 3, 6x squared plus 21x minus 12. That's another possibility. Right? This is a factor, meaning it has a steeper value. Right? Or if I put a half on the outside, that means it'd be wider, but still going through the same zero. You guys recall that? Making it steeper, wider, and all those things. Okay, that's a possible solution. How do you guys feel? Not too bad? Okay, that's it.